Hello, my name is Rob Reynolds. Welcome to Mat-073, where we're going to get our first section in Chapter 2. Today we're going to look at how to plot some points on a Cartesian system. Ordered pairs are going to be x, y, where we're going to be moving left and right for the x values, and we're going to be moving up and down for the y values. And we're going to look at some graphs of linear functions and nonlinear functions. So first of all, we're going to talk about what an axis is. We've got an x-axis and a y-axis. We have the origin, which is at the center, 0, 0 is the origin. And then we have the first coordinate and the second coordinate, which makes up our x and a y ordered pair, which is our movement, left or right, up or down. So our first example is to plot the point 2, 3. I'm going to move 2 units to the right, 3 units up. And that will be in the first quadrant. So quadrants we'll get to in a moment. To plot this, a -4, instead of moving 4 to the right, I'll move 4 to the left. And since this is a positive, I'll still move up. So I'm going to go 1, 2, 3, 4 to the left, 1, 2, 3 up, and there's the point 4, 3. Again, there's the x-axis, left to right. The y-axis is up to down, and this is called the origin. So you start at the origin, and you do a left or right movement, and then from there you go an up or down movement. And here's the solution again, 4 left, and then from that position, don't put a point at 4 left, just move 4 left, and then 3 up. So again, I was talking about quadrants, and the first quadrant is your positive quadrant. That means you're moving to the right and up. Your second quadrant is your negative positive. That's to the left and then up. The third quadrant is negative negative. And the fourth quadrant is positive, negative, which means you move to the right and then move down. So checking to see if an ordered pair is a solution or not, we're just going to plug in our x and our y values. So let's try to let x be 2 and y be 3 and see if it works. So 4 times the 3, which is the y value, 3 times the 2 value, and we're just going to check the left to see if it's equal to the right. So 12 plus 6, 18 equals 18. That looks pretty good. Let's check the 1, 5. Again, this is my x for the 1, and the y value is going to be a 5. So when I plug this in here, instead of 4 times y plus 3 times the x, I'm going to plug in my x value goes here as a 1, and the 4 value, next to the 4 comes the y, which is a 5. So let's check this. 20 plus 3 does not equal 18. So I would say yes to the first point, and I would say no to the second point. So the first point is true, the second point is false. The graph of the equation is a drawing that represents all of its solutions. So it's infinitely many points. So I might have 2 points here, but I have infinitely many points maybe in between, and that's what forms the line. So we're going to learn how to construct a t-chart and then plot a point and then at least 2 other points to verify. So if this is my function, I'm going to let x be anything I want. Typically we go from -2, -1, 0, 1, and 2. Sometimes this doesn't work because I don't get a good image of the function, but let's try this. So this is the y value, which is 3x. So every time I see an x, I'm going to plug in these x values. So 3 times -2 is -6. 3 times the -1 is -3. And so you can see here comes my ordered pairs. So the xy ordered pair would be -2, -6, -1, -3, and I would continue this. If I plug in a 0, I'll get a 0. Plug in a 1 is 3, and plug in a 2, 3 times 2 is the 6. So these are all the ordered pairs that I'm going to plot. So 0, 0 is an ordered pair, 1, 3, 2, 6 off my graph. Plotting this one is to the left and then down 3, and this is to the left 2 and down 1. Doesn't look like it fit. Oops, that's a 6. Good, so it does fit. Again, off the graph. And then I would grab a straight edge and try to graph this line through those points. So again, construct a t-chart and connecting all the points. So that means that I don't know what this point is, but it's also a solution. to this function. So there's infinitely many solutions. X could be 1.97, and if I let x be 1.97, then I'm over here 1.97 and I have some y value and I don't know what that is, but it exists. So let's try it again. Again, I typically use -2, -1, 0, 1, and 2, but you can choose any points you want for the x values that might be helpful for you. Again, maybe this is way off your graph, so if the function looks like this, it doesn't make sense maybe to let it be 0 because you might be way off your graph. So you can choose any value for x you'd like. So let's plug in the -2. That's -4 times -2 is 8 plus 1 is 9. This is 4 plus 1, 0 plus 1, -4 plus 1, and -8 plus 1. If these don't fall in a straight line, I know this is a linear function because it's to the first power, then I know that I've graphed something incorrectly and I'll go back and I'll make some adjustments. So let's see if all these points fall on a straight line. So we'll start with this one, -2, 9, well that's off the graph, but it's up here somewhere. -1, 5 is on the graph. 0, 1, don't go left and right, go up 1. This is go to the right 1 and down 3. That looks like it's falling on this line here. And 2, -7 is going to be off the graph again, but it does look like I have a function that's going to be connecting of the dots. So notice this time the line is swooping down from left to, you read a line like you read a book from left to right. So if it's going down, then notice that that tells you that we have negative slope here. In our other example, we had positive slope because you're moving from left to right up. We'll talk more about positive slope and negative slope in just a moment. But here's the t-chart that the author did. And here was the graph that we matched. So sometimes the function is not given in slope-intercept form, which was the y equals mx plus b. Sometimes it's called standard form, and we're going to treat this just the same. You could spend the time to solve for y, but there's no need. We're just going to let x be the same numbers that we've always been letting x be. So if I let x be -2 here, I'll get -2 plus 2 times y equals 6. So a little bit of math, I'll subtract off 2, and y will equal 2. So my ordered pair is -2, 2. If you would like to spend the time to solve for y, it might be a little bit faster because I won't have to do so much number crunching on each ordered pair. So to solve for y, which we've done in a previous lesson, solving for variables, you could subtract off x from both sides and then divide every term by 2. So this really says y is equal to -1/2 x plus 3. So if I plug in a -1, I get fractions, but 0 is pretty good. If I plug in a 0, that'll wipe out the x term and just leave me with a 3. I'll skip the 1 term, but the 2 is not bad because it says -1/2 of 2, which I know this is -1, and -1 plus 3 is 2. So it looks like 2, 2 might also be a point. So plotting these, I get -2, 2. Looks like I've made a mistake somewhere. The reason that I know that I made a mistake is there's no way to plot. This is a linear function because it's x to the first. I can't plot this point, -2, 2, and then plot this point at 2, 2. It doesn't make sense because that's not going to match my other points, which is at 0, 3. So let's look at this guy. I think if I let x be -2 right here, this should have been a negative, which I should have added 2 to both sides, giving me an 8 over here. So then if I divide by 2, I get the y value should have been 4. So -2, 4 makes a little bit more sense. At least that's falling onto this line. So I think that's my error there. So it looks like 3 points are lining up, and that's the purpose of checking multiple points, is because if you have an error with just plotting 2 points, your line could be wrong. So here's how the author chose their points. Again, what you let x be does not matter, but it was a little bit helpful to let x be an even number in this example because it made the points a little bit nicer. So a linear function is anything that's going to be graphing a line. We also have nonlinear functions that we're going to look at. I know that this is a nonlinear function because it's not x to the first. This x to the second we haven't looked at. It's actually called a parabola. But let's just go ahead and plug in our same numbers that we've been plugging in all along for x. Again, you can let this be anything you want. Sometimes these x values are not helpful. You might want to choose other x values, but for now, negative 2 squared is positive 4, minus 1 is positive 3. So I'll plot that point, negative 2, 3. To plug in a negative 1, I'll do a negative 1 squared, which is 1, minus 1, which is 0. So I'll plot the point negative 1, 0. If I plug in a 0, I get a negative 1. Plug in a 1 squared is 1, minus 1 gives me back to 0. Now remember, this is not a linear function, so in this case, I'm okay with these two being zeros. And if I plug in a 2, I get the 4 minus 1, which is back to the 3. And it looks like there's some symmetry going on, and that should happen with parabolas. So I have a nice parabola. And I mispronounced that on purpose so you could see that it kind of is a bowl shape. So it's actually called a parabola. But you can remember that it graphs a bowl. So that's all for your x. Every time you see an x squared function, it should be in the shape of a bowl. The absolute value function is a function that you should be able to recognize, but again, if you haven't seen it before, I would go back and just plug in the negative 2, negative 1, 0, 1, and 2 for the x values. The absolute value of negative 2 says distance from 0, which is 2 units. It's not concerned with the direction. So this is just a 2 plus 3, which is a 5. The absolute value of negative 1 is 1, plus 3 is 4, 3, 4, and the absolute value of 2 plus 3 is back to the 5. So if we were to plot these points, negative 2, 5, negative 1, 4, this looks like it's in a straight line, but actually when I get to the 1, 4, it actually forms a V. And you can remember that because absolute value is spelled with the letter V. So whenever you see an absolute value function, it should graph a V. So again, recapping some of the techniques of this section, we should let x be anything you want, so you can let it be 0, 2, and 4, but just make sure that if you chose something like 10, it may be off your graph and it may not be helpful. But I would definitely choose more than 2 points because you might be making a mathematical error. 2 minus 1. So let's see if we just plot these 2 points. 0, negative 1, 2, 1. And then I'm going to pick up, not 10 because it's off my graph, so I'll pick a 3. It's nice to pick some positive numbers and some negative numbers, but 3, 2, it looks like I have a nice linear function here. This is not exactly in the form y equals mx plus b. That's actually the next lesson, so you don't need to convert this. You can just plug in values. I would choose a negative number. 0 is always nice to pick, and then I would pick a positive number. Be careful here. 3 minus a negative 1 turns out to be positive 4. Again, the rule is instead of subtracting a negative, you can add the opposite. To plug in a 0, 3 minus 0 is just 3, and 3 minus 2 is 1. So plotting these to make sure that they fall into a straight line, I get 0, 3, and 2, 1. And the reason why I know it should be a straight line, again, is because it's x to the first. So I'm not looking for a parabola, I'm not looking for a V, I'm looking for a line. So this one also graphs a line. I could plug in a 0 here, and in the next lesson we're going to talk about what the slope is and why I keep putting it into this y equals mx plus b form. But for today, this lesson is just all about a t-chart. Maybe choose a negative number, 0, and a positive number. I would definitely, at minimum, choose 3. To be safe, you could choose more. Now, 1's not very helpful because I don't want to take 1/3 of 1 and try to plot negative 1/3. So I'm going to back up and maybe change this -1 to something that might be a little bit more productive, such as 3, because I know 1/3 of 3 is just 1. 0 is good because 1/3 of 0 is 0. Now 2 is not a good number because I don't want to take 1/3 of 2. So you could choose again a 6 or a 9. I'm going to choose a negative number so I can have at least one positive number and one negative. I'm going to choose -3. So y is equal to 1/3 times the -3 plus 0. And that's going to be -1 plus 0, or just -1. So there's the y value, -1. So we'll plot some points. 3 to the left, -1. Down 1 is this last guy. 0, 0 I have, and then 3, 1. Yep, that looks like these 3 points fall on a straight line. Starting here, some of you know the technique. This is called the y-intercept. We're going to get more into that the next lesson. If you just want to graph like this, My Math Lab, when you're doing your homework, will not know if you're doing the T-chart or not. I'm not a big T-chart fan. So if you know the shortcut method by just starting with the y-intercept and you know that the slope is defined as rise over run, I don't mind if you don't form a T-chart and you just do this rise 1, 1, 2, 3, 4, rise 1, 1, 2, 3, 4. Instead of going up and to the right, you could go down and to the left. So this will also create a linear function because it's to the first power. This one, some of you know how to graph this using x-intercepts and y-intercepts, which again we're going to talk about in a later video. But to find an x-intercept, it just means where it crosses the x-axis, you can let y be 0. To find a y-intercept, you let x be 0. And that makes it pretty easy, because if you let the y be 0, that'll eliminate this term, and it says x is -6. If we go back and let the x value be 0, that'll eliminate this term, and I just have to divide both sides by 2, and I get y equals -3. And then these 2 points will determine the line. And again, I know it's a line because it's an x to the first power. So here's other methods of graphing besides T-chart, which you're certainly welcome to use. We'll cover more in other videos. I see that this is an x squared, so again it should graph a parabola. Some of you may have seen this before, where if it's a negative, it's not going to be a parabola going up. It should be a parabola facing down. So if you know the general shape of these, sometimes it makes it just a little bit easier to graph. If you plug in a 2, the opposite of -2 squared, don't square the -2. It's actually a -4. Be careful on your calculator. You need to put parentheses around it if you want to square the negative. This is a +4, but if it's the opposite of 2 squared, that'll actually give you a -4. So if you plug in a negative value, that says the opposite of -2 squared, which is the opposite of 4, which is -4. So notice this duplicates itself, which is fine because it's a parabola. So 0, 0 is a point, 2, -4, and -2, -4. And that's forming that parabola shape that I thought we were going to be getting. This would be another parabola facing down, but it's moved up 3 units. So some of you know that it starts here, and then if this is a 1, that's a movement over 1, down 1, over 1, down 1. I will review these techniques more in later videos. Again, the purpose of this, if you've never seen this function before, I would do a T-chart. So that's really the purpose. Plugging in a -2, -1, 0, and a 1, and possibly even a 2. 2 is not very helpful, so I'm going to plug in a 3. 3 over -3 is -1. -1 is not bad because I get a -3. This is undefined. We haven't talked much about that. That's going to be an asymptote. 3 is not helpful, so I'll plug in a, 1's not bad. 3 divided by 1 is 3. But let's change this 2 to a 3. 3 divided by 3 is +1. So plotting these points, -3, -1, -1, -3. An undefined value is a asymptote, which is what the function approaches but never crosses. And then this says what? A +1, 3, and a 3, 1. So if you needed more points, you could graph these, but I know what this shape looks like. This is where it gets close to this asymptote here, and it gets close to this asymptote here. So it's called a hyperbola, and that happens always when I have x in the denominator. Again, absolute value, I know it's going to graph a v, and this just says it's up 2 units. So I'm going to go over 1, up 1, and graph my v. If you would like to make a t-chart, you certainly could. This is a cubic function. You haven't seen that before, but I know the general shape of cubic functions look like this. It almost looks like it's going to form a parabola, but it's in the first and the third. And this says it's going to start 2 units down. So I'm going to go over 1 up a, which is, this is going to be my a value, ax cubed. And so if a is a 1, I go over 1 up 1, over 1 down 1, and I can kind of see the general shape of this. So if you know the general shapes of cubic functions, it makes graphing much easier than spending a lot of time doing t-charts. So we'll explore more of these other functions that are non-linear functions in later lessons. I hope this was helpful. Email me with questions.